Yes, hello guys. Today I will talk about uh, surfaces or area of surfaces of uh, area of surfaces of revolution in case of polar equations. Okay, now polar equations are there. Okay, as I promised you that in the next lecture series I'll talk about polar equations. When the curves are given in polar form, then what is the surface area of surfaces of solids of revolution? Area of surface is of solids of revolution. Okay, so area of surface is in case when we have revolved, okay, the area is revolved around or is obtained by revolving an arc of a curve or the curve given here about an axis or about a line. Okay, about an axis or about a line. These are the two cases about an axis. Now in case of polar equations, I'll talk about two formulae which are in case when the curve is revolved about the initial line. Second case is when the curve is revolved about a line which is at theta equal to pi by 2. That means it is perpendicular to the initial line. Okay, so at initial line theta is 0. Okay, so this is the at initial line, about initial line it is first case. Second case is when the curve is revolved about the line which is at theta is equal to pi by 2 from the initial line. So it is perpendicular to the initial line, theta equal to pi by 2. Okay, so that is the second case. And third case I'll talk about when the curve is revolved about any line other than the two axes, x and y axis, other than the two axes. If a curve is revolved about any line, that line is given to us. Okay, in that situation, the third formula I'll talk about, or these three formulas, let me discuss about. And after that, these questions are solved. Okay, then I'll solve these questions which I've taken from student queries, as I always say, online queries, mostly online queries, and in class study also, because in class we clarify the doubts of the students in the class. But in case of online queries, I'm just discussing about these questions which are helpful to almost all kinds of students. They are studying, they are correspondent students, or they are distant students from any country. Okay, especially India and okay European countries. Okay, so they can understand that what is this topic about. Okay, area of surfaces of solids of revolution in case when polar equations are given. So let me discuss about this. Now in case of polar equations or polar coordinates, polar equations or polar coordinates, in case of polar coordinates, okay, two formulas are used. Two formulae or formulas, okay, both forms are accepted or formulas are used. Number one, when the curve is revolved about the initial line, let me talk about. This is the curve here, or this is the curve. Now this curve is revolved about, this is the initial line. Let me take OX, this is the initial line. This is any point we have taken here. Let me take P, R theta. Okay, this is theta angle, this is R here. Okay, so in case of polar equations, if I revolve this curve about this line, okay, between the limits, whatever the limits are given to us from this point P to Q, okay, that limits we will take, but the formula is used is 2 pi y into ds. Why? Because I take this strip line, okay, about the, so this is y into dx. Y into ds, in case of limits, let me take here theta 1 to theta 2. So this is the area of surface. Area of surfaces of revolution. Surfaces of solids of revolution. Of solids of revolution. This is the first formula which I have to use. Theta 1 to theta 2. Limits are 2 pi y into ds. In case when theta here is 0 on this line. This is initial line here when theta is 0. Okay, and second line is this at theta equal to pi by 2. If I revolve this curve, or it may be the curve, or this may be the curve, in this situation let me take this is the curve here, and this is P point here. And take this P point, but in this case I'll take here perpendicular to this P, drop perpendicular from P to this line. This is elementary strip in that situation. When curve is revolved about the line which is at theta equal to pi by 2, then second formula, this is the first formula, and second formula, when the curve is revolved about the line at theta is equal to pi by 2, so perpendicular to the initial line, a line which is perpendicular to the initial line, and the curve is revolved about that line. In that situation, the formula is area, required area, let me take required area. In that situation will be limits again theta 1 to theta 2. Limits we will take here will be something else. This is 2 pi into x into ds. This is delta s here, and this is x coordinate of p, and here it is y, sorry, this is y here, y coordinate of p. Okay, so in this case by ds, 2 pi by ds, in this case 2 pi x ds. These are the two formulae in case of polar equations. Okay, so I'll talk about them. Third case is that when a curve is revolved about any line, this is the curve, and suppose this is any line other than, let me take any line here, this is any line O, let me take here O, and this is K. If I revolve a curve at this, we have taken P point here, and if I revolve this curve about this line which is other than axis, this is any line, okay, which is other than axis, then what we do, we drop perpendicular from P, and we take this is Pn here, and again this is PQ, this is delta S here. Okay, so PQ and this is Q point, and let me take here, this is N, this is M point, no problem. So in this case, what is the area? The third point is when the curve is revolved about any line other than the two axes, other than the axis. In that situation, this formula will be this. The formula used is again limits. We will think about that. What is the limit on the curve? Okay, and this is 2 pi into Pn. This Pn perpendicular length of the perpendicular length from the point P on the curve to the line about which we have to revolve this curve. Okay, so that is Pn into ds again. Now in this case, this ds will be written as ds d theta into d theta. We will calculate. In this case also ds upon d theta into d theta. We have to differentiate the given curve for the length s here. S is the length of the curve from a fixed point P to another point P. So from a fixed point A to another point Px by or P r theta in this case. Okay, so that is the area of the curve. Okay, so this is what these three formulae we have actually used, and there are three cases here. This is in case when curve is revolved about the initial line. This is about the line which is perpendicular or at theta equal to pi by 2, or perpendicular to the initial line, theta equal to pi by 2 in this case. So this is the formula by x. So these three formulae we will use. Okay, or these questions are based on only these three formulas. So let me take questions one by one. Okay, now first question, what does it say? So today I am talking about area of surfaces of solids of revolution. Okay, in case of polar equations, this is polar equations here. So area of solids of revolution, area of surfaces of solids of revolution, area of surfaces of revolution, or surfaces of solids of revolution. A solid is obtained which is having some surface or area. We find out surface or area, the same thing. Surface, if we have to handle surface, curved surface or something, that means area we are calculating. In this case, question number 1, let me take. Now question 1 says that the arc of the cardioid are equal to, let me take question number 1 here. It says the arc of the cardioid, are equal to a into 1 plus cos theta. This is first equation. Okay, is a revolved, okay, including between minus pi by 2 to is less or equal to theta is less or equal to pi by 2, or maybe less theta lying between minus pi by 2 to plus pi by 2 is rotated about the line theta equal to pi by 2. Try to understand. Find the area of the surface generated. So the arc is revolved about the line at theta equal to pi by 2. This is given to us. Find the area of the surface generated. You have to find area of the surface generated. That is the point here. Now what is the curve? Let me draw that. This is also not working. Okay, now let me take what is the curve here. Now if I draw a curve, let me draw that curve. Now if I put theta equal to 0, then it is twice a. Okay, and when theta is pi, it is 0. So theta is pi, that means 0 is here. This kind of curve will be there. This is cardioid. Okay, and in this case theta is pi by 2 at this point. Okay, and here theta is plus pi, and here theta is 0. Initial line is this. Okay, this is O4 x. Let me take x here. Okay, this is A point. Now this is the arc from this point A to, let me take, this is B point. Now this arc is to be revolved about. Let me take a P point here, and this is Q point. Okay, and we take PR theta or something. This is R and this is theta. This is theta angle here. Okay, and this is Y, or we take this as Y. If in Cartesian coordinates, if it is X and Y, then this is Y here. And this is delta S, length of the arc, smaller length. So in this case, and this is R. Now what is the then? So here limits we have to take from theta equal to 0 to pi by 2. It's given clearly. Okay, so what is the area of this? Okay, the solid which is the surface which is generated by revolution of this arc AB, which is from 0 to pi by 2, because this is about the initial line. So this initial line, we have to revolve this arc, total arc. So here limits are minus pi by 2 to plus pi by 2. So this whole arc, if I take this point B dash here, okay, because this whole arc is revolved about this line, that means this is also included. Try to understand. So this will also be included. That means twice of this. And or we can just say, if I take my limit minus pi by 2 to plus pi by 2, then it's okay. Then they have not to multiply by 2, because this whole arc is revolved about the initial this line, which is at theta equal to pi by 2. That is the point. So therefore, area of this, let me find out. So area of the solid of the, this is, let me take solution here. So let P R theta is the point. This is P R theta, or yeah, here we can take what is x and y coordinate of this. So x equal to R cos theta and y equal to R sin theta. So here, okay, x equal to, we take R cos theta, okay, and y equal to R sin theta. This we always take in case of parametric form. Okay, parametric form is there in this sequence, or we can take the polar coordinates. X is replaced in polar coordinates R and theta in this way. X is expressed R cos theta and y is taken as R sin theta. So these we will use. Okay, so and then for the point of dr upon d theta we have to calculate. Here r is equal to, let me take this is same value 1 plus cos theta. This is first equation. We have to differentiating it with respect to theta. Differentiating it with respect to theta, we get, what do we get here? This is dr d theta is equal to a into minus sine theta. Try to understand. That means minus a sine theta. Why? The differentiation of cos is minus sine theta. Differentiation. So therefore dr d theta equal to minus a sine theta. This is value of this. Now we know that ds d theta in terms of polar equations is r square plus dr d theta whole square. That's the point. Therefore r square is that value, a into 1 plus cos theta. Let me write here, r is a into 1 plus cos theta. This is a square into 1 plus cos theta, because this is r square. R is this, and plus this is a square into sine square theta. Now positive. If I take a common throughout, it will come out. It is a 1 plus 2 cos theta plus cos square theta plus sine square theta. Now left over. So, but sine square theta plus cos square theta is equal to 1. Since sine square theta, let me write here, plus cos square theta is equal to 1, trigonometric identity is equal to 1. Therefore, since this is equal to this from trigonometric identity, therefore this is 1 plus 1, 2. So we can take a 2. If I take common, this 2 plus 2 cos theta, that means 1 plus cos theta. Now left over, this is equal to a. Within bracket we can write, now what is 1 plus cos theta? This is nothing but 2 cos square 1.2 theta. Why? Since cos 2 theta is equal to 2 cos square theta minus 1. Now 1 plus cos 2 theta equal to 2 cos square theta. Trigonometric identity. Therefore 1 plus cos theta, when single angle is there, then angle will be halved here. This is 2 cos square. That means twice a cos 1.2 theta. This is the value of ds d theta, or ds d theta is equal to twice a cos half theta. Now let me find out that what is the area of the surface generated. Therefore required area, because the ds upon d theta we have just calculated. Therefore required area of the surface generated is equal to, this is minus pi by 2 to pi by 2. We can take, or twice we can write of this, but this is also in total. So curve, total curve, this whole curve is revolved about this line, which is at theta equal to pi by 2. It is 2 pi into ds, can be further written as, this is plus sign twice 0 to pi by 2, because when minus a to plus a it is there, then we write what we write, twice of 0 to pi by 2. Now this is 2 pi, y is here r sine theta, this one y equal to r sine theta, and ds upon d theta, let me write here, into d theta. ds upon d theta is this value. We can write it as, this is 4 pi 0 to pi by 2. Here it is r is now a into 1 plus cos theta. The r is this is r sine theta as it is, that sine theta as it is, into twice a, because ds d theta is twice a, into twice a cos half theta into d theta. Okay, now further we have to substitute these values. So let me further solve them. Therefore, this is sine theta here, 1 plus cos theta here. We can write them in different connotations, 0 to pi by 2. or if I just multiply them, 1 plus cos theta, okay, sin theta is also to be written down, no problem. Then we can write them in the same way. So that is the point. What I'm doing here, I'm sorry, this is why I've taken y. I was just thinking about that, why this is x into ds. I'm sorry friend. I just explained that this is about the line x equal to, sorry, here ds upon d theta is okay, we have calculated twice a cos half theta, but formula is not this. But what is the formula? The required area, I'm sorry, the required area of the surface generated, because in this case, I'm sorry, for this curve is revolved about this axis, which is perpendicular to the line, initial line, that means generated. So this is equal to twice pi, let me take here minus pi by 2 to pi by 2. This is okay, but 2 pi into x ds. Why? Because this is this line, not this is not required here. We have to draw perpendicular from this point. Let me take here P point. If I draw, I'm sorry, this is not the point here, but we have to draw perpendicular to the x-axis. This is P point here. Okay, and let me join this. This is R and this is theta undoubtedly, but this is Pn, this is PQ, this is PQ here, and N and M. Let me take, so Pn is this is x coordinate here. Let me take x and y. X and y are these coordinates. So this is, I'm sorry, but I took y into ds. But y into ds is when we are taking about initial line. In this case, it is at line which is at theta equal to pi by 2. We always take x into ds in this case. I'm sorry. Now substituting the values, so this is twice, because minus pi by 2 plus pi by 2, that means 2 into 2, 4, 2 pi into 0 to pi by 2. Let me write shortcut. X is now this r cos theta. Sorry, so this is r cos theta into this value of x here, but r we will substitute, but before that let me take this is ds upon d theta into d theta. So ds upon d theta is this value twice a, this is twice a into cos half theta into d theta. Okay, so it will give us 4 pi 0 to pi by 2 now. Now r is nothing but a into 1 plus cos theta. Okay, and this is twice a. Okay, and this is okay, x here, so r into this, and cos theta is also there. I'm sorry, here it is cos theta, this value, into twice a cos half theta d theta. Now this 2 will also come out, so that value is, now it can be multiplied inside, or we could write here this is 2 cos square theta by 2. So cos square theta plus cos theta, or we can just integrate them. Okay, now let me write here, this is 4 pi 0 to pi by 2 into a into this value is 2 this value is twice into cos square theta by 2, cos square theta by 2, 2 cos square theta by 2 into 2a cos half theta into d theta into cos theta, because r into cos theta is there. This is into cos theta. Cos, this is cos 2 theta type value. We can just change it into cos 2 theta. Okay, could be written as, let me now change it into different form. What that value, let me write here. Okay, so this could be changed into cos theta into cos theta. I have to convert them into sine, so that sin theta can be taken as t and then cos theta can be taken as other values. So that will be better. Let me take that form. So it is equal to 4 pi, 4 to the 8. This is 8. Let me take. This is 8 pi now. 2 into this. Now this 1 plus cos theta and cos theta are not changed yet. Now let me change them. It is a into a is a square. Let me take 8 pi a square. I've taken outside. 0 to pi by 2. Now here it is 1 plus cos theta. I can write it as 1 plus cos theta is 1 minus 2 sine square theta by 2. 1 minus 2 sine square theta by 2. This is value of cos theta. This is also cos theta. So 1 minus 2 sine square theta by 2. 1.2 theta. This is what value? Value of cos theta here. Cos theta is 1 minus 2 sine square theta by 2 into cos 1.2 theta by 2 into d theta. This is the value now. Now this is 2. Let me write here. 8 pi a square 0 to pi by 2. And this is nothing but 2 minus 2 sine square 1.2 theta by 2 into 1 minus 2 sine square 1.2 theta, okay, into cos 1.2 theta into d theta. Now we can assume, let us take sine theta by 2 equal to t. If I substitute, then it can be converted into t only, the variable. Let us take, or putting here, let us take sine half theta is equal to t. Let me take. Therefore, differentiating it with respect to t, differentiating it with respect to t. So we get here, this is cos 1.2 theta into 1.2 into d theta equal to dt, or cos 1.2 theta d theta equal to 2 dt. This is cos 1.2 theta into d theta equal to twice into dt. What are the limits here? So if I put theta as pi by 2 here, sine 1.2 theta we have taken as t. If I put theta as this, so sine pi by 4, so this is pi by 2, so it will be pi by 4. Pi by 4 is 1.2. Okay, so t is equal to 1.2. So sine pi by 4 is 1.2. At 0 it is 0. So limits, let me write here the limits. Let me write here the limits. So here the limits, let me put at theta equal to pi by 2, g is equal to sine pi by 4. That means 1.2. And at theta equal to 0, lower limit, that will be equal to, by that t equal to 0, 0 to 1.2. Sine pi by 2 by 4 is 1.2. So let me write here. Now this 2 can be taken outside, this 2, and 1, 2 will come here 2 dt. Okay, so this is 16, first 16 into pi a square, and 1 more will come, that let me still write 0 to 1.2. Okay, and this is 1 minus t square now. Sine half theta we have taken t. It is 1 minus t square into, this is also 1 minus t square, 1 minus 2 sine square theta. Okay, and this is now 2 dt into 2 dt. So this 2 will again come out. This is 32 pi a square. Now 0 to 1.2. Now if I whole square this, is 1 minus t square whole square. That means 1 minus 2t square plus t4. It will be into dt. This is the value. We can integrate this with respect to t now. Let me write here. Therefore, required area of the surface generated by this arc, generated after revolution, generated by revolution about line that theta equal to pi by 2 is equal to 32 pi a square. Now integration of this will be t minus this is 2t cube upon 3 plus t 5 upon 5 upon 5 limits now 0 to 1.2. At 0 it will be 0, only at 1.2 the value will be there. Let me find out that what is that value. Let me now further solve it. So it will give us 32 pi a square. It is 1.2 because that's t 1.2 the upper limit. It is minus 2 tq means 1.2 whole cube, that means 1.2 root 2. Okay, so that means upon 3 into 2 root 2, root 2 cancel out, 1.3 root 2 plus it will be now root 1.2 5 times, 1.2 5 times, that means 4 root 2, 1.4 into 5 root 2. It is now okay. So this is 32 pi a square. Now let us take 1.2 common throughout. It will come out as 1.2 out. It is 1 minus 1.3 plus 1.20. Okay, so 23 is 60 if I take LCM. 32 into pi a square upon root 2. It is 60, let me take LCM. And it is 60 minus 3 times is 20. 20 and plus this is 3 here. Okay, so 63 minus 20 coming out as different terms, so no problem. Now this is the value. 60 minus this is 40, 43 upon 60. So it is 32 pi a square upon root 2 into 43 upon 60. Now 43 is prime number, so cannot be cancelled out. Only 60 and 32 can be cancelled out. This is 4, 8 is 32 and 4 times. This is 15 times. 15 fours. Now further it cannot be cancelled out. It is 43 into 8. The value is, it is coming a different kind of answer, no problem. And the area of the surface is later. The arc of the curve, this in